Welcome to lesson 1.4. The title of this lesson is Graphing Sequences. The objectives are to recognize the difference between arithmetic and geometric sequences from their graphs, and to use graph to check whether a recursive formula is a good model for the use of data. Now, we've touched on graphing sequences in the last 3 lessons, in particular at the end of lesson 1.3, but we do want to wrap it up. We do want to talk about this a little bit more. So this is actually one of the shorter lessons that you're going to be watching. So what I want you to do is I want you to open your book to lesson 1.4 investigation. It is on page 51 of your book. And I want you to pause this video and I want you to look at these. Okay, I want you to actually do the investigation. What you have here are 6 different tables, 6 different recursive formula, and 6 different graphs. Okay, again, I want you to pause right now and I want you to try this. All right, and then as soon as you're done matching them, then press play again. So here is the solution. And I hope that you got every single one of those. Okay? And again, as I said before, this is probably one of the easiest lessons that you will be watching. But let me summarize the lesson. In general, of course, there's always exception to the rules, but in general, the general shape of the graph of the sequence term gives you the indication of the type of sequence necessary to generate the terms. So for example, arithmetic sequences have a linear graph. That's a straight line. Geometric sequences have a curved graph. When the common difference of an arithmetic sequence is positive, the linear shape slopes upward from left to right. Let me draw you a picture of what that looks like. That's what it looks like, right? When it's positive, it goes up. When the common difference of an arithmetic sequence is negative, the linear shape slopes downward. So that's what it looks like. Okay. When the common ratio of a geometric sequence is greater than 1, the curved shape increases from left to right. That's what it looks like. When the common ratio of a geometric sequence is between 0 and 1, the curved shape decreases from left to right. And it will usually decreases to 0. Okay. Shifted geometric sequences level off at a non-zero value. So in general, if it increases, it will level off. If it decreases, it will also level off. So these are the type of graph that we're talking about: arithmetic, linear, geometric, and shifted geometric sequences have a curved graph. Right? Why do we need to know this? Why are we learning about this? Well, weather forecasting is one career that relies on mathematical modeling. They use computers and sophisticated models to monitor changes in the atmosphere. Trends in the data can help predict the trajectory and severity of impending storms, such as hurricane. Okay? So for example, if we have a hurricane, that's coming in and the wind is blowing west. Well, the hurricane is not going this way. So according to the wind, the trajectory is that it is heading towards the United States. Okay? And that's when we use mathematical modeling to indicate where is it going to go. Then we can let the people who lives on the coast knows that they have a storm coming and that they can expect this. So this is just one way that we can use math to predict the storms or anything, impending storms. All right? So easy lesson. As always, feel free to come in. Feel free to bring questions if you have any. I certainly welcome it.